Hello, my name is Pachalapon Umsoy. My student ID is 64105500961. And today I will present the second project assessment. And our topics is EEG-based prediction model for drowsy driving detection. I will present with my teammate's name is Ashiraya Sitharot. Her student ID is 64105544141. So this is our table of content. I will start. The first one is our project overview and objective. So our problem statement is drowsy driving is a major cause case of road accident leading to numerous injuries and fatalities worldwide. And our project can describe in just 3 sentences. The first one is use EEG Drowsy data. The second one is we want to create a model prediction. And the last one is to alarm to driver or user in real time. So our goal and objective is to develop a model that uses EEG data to detect drowsiness in driver in real time, enhancing road safety by preventing drowsy driving incidents. And our outcome is reliable real-time alert system that detect driver drowsiness based on EEG data. This system can help to prevent an accident by notify driver. And our data set I have explained you in our last presentation, but I will tell you again that we use the EEG data to use in this model. So it's have 5 data. The first one is delta, the second one is theta, the third one is alpha, the fourth one is beta, and the last one is gamma. So I will tell you again what the signal it's telling us. The first one is delta. It's tell with the deep sleep and restorative function. Theta is related to drowsiness, early stage of sleep, and relaxation. Alpha is observed during calm and relaxed state, often linked with the minimal sensory input. Beta is indicative of active mental engagement, focused attention, and cognitive process. And the last one is gamma is associated with higher cognitive functions such as memory processing and problem solving. So in this data, we will have to have time. So we just add the column with telling time to be a memorable in the time in the second. So we have to separate the data into functions. The first one is classification, that it's telling number one or it's we will want it to be alert, and the second one is zero, which is telling you it was drowsy. And the feature that we use is we use just EEG. So we have to cut the attention column and meditation column because from the data that we use in other projects, they tell the attention column and meditation column is cannot trust, so we have to cut it off. and add the column of time.
Okay, this part I will explain coding in Power BI when I use Python. And first step, importing library. I import a prompt for casting true for time series and pattern for data, data structure and data frame and matplotlib for create a visualizing and graph and chart. And next step, loading and preparing the data. This line lead the data sets from the CSV file location on desktop, and then I converting time to second. The result is the time in second, and convert and by the converting hour to second, minute to second, and keeping the in the second, and then creating the DS column for format. Um, and step three is separating data by classification. Alert data is when classification equal one, and Drowsy data is when classification equals zero. And step four, creating forecast function. Function forecast column either define handle the forecast process for any given vector like delta, theta, gamma, beta, alpha, and then preparing the data from the prompt. Um, and next is training the prompt model. The prompt model is instantial, and the model is the trained using the forecast data contain the DS and the select feature Y, and then create the future data for predict. And I use the make future data frame period equal 120 is the create the future time data for the next 120 seconds, and the model predict this value from this future data frame, and then adding the time and classification information to the forecast. And step step five, um, plotting the forecast result. I plot in create the visualized for the forecast by y, and the Bura is a predicted value, and the area is a confidence interval for the predicted, and the backdot is the accuracy data using the trained model, and red X mark is a error stage, and green mark is the Drowsy stage, and step six is learning the forecast for the data, and this code for the delta. And this is a result when I use the code, and the code show x-axis is the time in second, y-axis show the predict value for the pocket model for the delta. This graph, first graph for delta, second graph for theta, and Burai is the forecast value, and Boo shape, Boo area is a confident interval. Show the range accurate data layer to the fall, and confidence and accuracy for the forecast, and for the back dot is a represent the real data, and X is a alert stage, and layers is a alert stage, and green is a Drowsy stage. And this is a result. I conclude the coding when data delta wave associated with sleep and brain recovery. When the diver is drowsy, delta level increase because the brain activity slow down. On the other hand, and the remain low in alert state, and theta wave is linked to the deep sleep and drowsiness. Some similar delta and theta level is least when the diver start feeling sleepy, but stay slow when they are alert. And alpha wave with relate to relax and focus, and the have two types: high alpha and lower alpha. High alpha level are higher when the diver alert, and while lower alpha indicator is in the drowsy stage. And beta wave indicator for alertness and deep thinking. High beta level drop when the diver is drowsy, and lower beta may slide in heat in this stage. And the last is a gamma wave with the represent intense metal activity. This level and high when the diver is fully and alert, but regret and drowsy set in. Okay.
And this is the last one. Before I tell you the next step, I will tell you what we have done first. So we have done the import data processing, printing data, forecast data, and define data range like drowsy and alerts. So our next step is to create the dashboard to monitor, and the second one is system send the alarm to user. And the last one is create this model to be an automate prediction. In this method, I think now our project cannot do because the information that we got it's not a real time data. So The last one of our next step, it will be on the next semester. So thank you for your attention.